So remember that in class we talked about contagion and we talked about how things can grow exponentially and they can get large really fast, or we talked about how things can decay and they can get small, really, really small really fast. And so what happens is we need a way to write those really large or really small numbers more easily. And what we do to be able to write those numbers easily is we use scientific notation. I could tell from some of your pretests that you've heard of this before, but I want to go ahead and I want to make sure that you realize what the real definition is for scientific notation versus not scientific notation. So what you're going to do is you're going to pause the video when I get done with the directions, and you're going to look at these two lists of numbers. You're going to look at these that actually are in scientific notation, and you're going to look at the list over here of numbers that are not in scientific notation. So these are good examples, and these are non-examples. And I want you to start to formulate in your head what you think the definition is for scientific notation. And then also, I want you to look at each of these numbers and decide whether you think it's in scientific notation or not. So before you can actually decide if you think these are, you need to, in your head, formulate your own definition. Okay? So look at those numbers, decide what all of the good examples have in common, and that's what's different from the good examples from the non-examples. Use that to form your own definition, and then if you think they're a scientific notation or not. Then when you're ready, go ahead and play the video, and I'll start giving you my definition. All right, so my definition of scientific notation, obviously you already know from my introduction that this is a way to write really small numbers or really big numbers. And so it has two parts, okay? Scientific notation is written in two parts, okay? It's written as a product of two things, and I'm going to define those two things. The first part has to be a number between 1 and 10, okay? And so the first part can't be anything smaller than 1, and it can't be 10 or larger. This second part is a number with a base of 10 to a certain power. Okay, we are going to use positive powers for large numbers. So when we look at this power right here, let's kind of go down here for some extra notes. We're going to use positive exponents for large numbers, and we're going to use negative exponents for small numbers. Okay, so going back to these three that you were supposed to classify, when I look at them, I can see that this first one is a number between 1 and 10 times the power of 10, so yes, this is in scientific notation. The next one, the first number is 32, so even though it's multiplied by a power of 10, no, this is not scientific notation. This 32 times 10 to the 5th would be the same thing as taking 32 times 10 5 times, which just basically means it's going to be 32 with 5 zeros after it. So how we can actually write this in scientific notation is instead of using 32, we would want to place the decimal between the 3 and the 2, because that's going to give us 3.2, okay? And then what we need to do is we need to figure out how many places are after that decimal, because that's how many times you're going to have to multiply by 10. There are 6 places after the decimal, so I'm going to multiply by 10 to the 6th power. So if I wanted to write this number, 32 times 10 to the 5th, which is the same as 3,200,000, I would write it as 3.2 times 10 to the 6th power. Next part, also not scientific notation, the 0.28 is too small. So it would need to be something like 2.8 times 10. So instead of multiplying 11 times, since I've got already one value taken care of, I would multiply 10 times. Okay? All right. So the other thing I want to talk about is when we use those negative exponents. So if I multiply a number, so let's say I'm multiplying the number 3. If I multiply that by 10 to the negative third power, okay, I want you to think about the fact that we talked about that 10 to the negative third power means the same thing as 1 divided by 10 to the positive third. So really what we're actually doing is we're taking 3 and we're dividing it by 1,000, okay? Which is why 10 to the negative third actually takes and moves the decimal from here, it moves it this way 3 times, because it's actually each time that we divide by 10, it moves it over to the left. So this actually equals 0.003. So we've got an example here. Meredith is doing a report on stars and wants to estimate the total number of stars in the universe. 125 billion galaxies, and then it says that in the Milky Way contains 100 billion stars. So we're actually thinking about 125 billion multiplied by 100 billion, okay? So 125 billion looks something like this. So I'm going to write this as scientific notation, 1.25. And then, like I said, we're going to count the number of spaces after to figure out how many times we're going to multiply by 10. So that would be 3, 6, 9, 10, 11. And then 100 billion would look something like this. So that would be 1 times 10 to the 11th power. And then if I'm going to multiply this by this, I'm going to take 1.25 times 10 to the 11th times 1 times 10 to the 11th. So rearranging around, because I know that I can multiply in any order I want, I know I can multiply the 1.25 by the 1, so that just gives me 1.25. And I know that I can combine 10 to the, I know that I can combine 10 to the 11th times 10 to the 11th because they have the same base. So I can use my power rules from last time. So I can think of this as 10 to the 22nd power. So that is in scientific notation approximately how many stars we might think are in the universe based on the fact that there are 125 billion galaxies and there are 100 billion stars in one of those galaxies. All right, before class, I'd like you to look at these two numbers and try to write them in scientific notation.